Hi everyone.
Hi.
Hey.
Hi.
I'm Matteo Collina on Twitter. Please follow me if you don't follow me already. If you follow me, send me a tweet or something. Always.
Will you follow us back?
Maybe. I'm here to talk about Node streams. Wait, I can sit. Okay. So I have a little bit cooler. I'm joking. I'm here to talk about streams and Node.js. So before we start about talking about streams, let's talk a little bit about NearForm. We are here, and there's going to be a raffle at the end of my talk. So before the last keynote, I'm going to do the raffle thing. We are hiring, so if you are a senior developer or a mid-level developer that wants to be a senior, I don't know. We are hiring. I just received a nice news that I need to hire 20 more people by the end of this month. So please help me out and come work with us. What we do JavaScript applications. We help companies develop and build and deploy JavaScript software. So also we are in designers and DevOps. So if you are a designer or a DevOps, we are hiring. So that's us. Check us out. We have nice t-shirts with nice blue. I don't know. That's what we do. And nice stickers. So there is also that. So what is a stream? Well, a friend of mine always, which is over there, Dave, hi Dave, always starts talking about streams, saying that a streams is like an array over time. So yeah, you have a flow of data coming through. It's true, right? And you have a flow of data, and you know, instead of having a big array with all your data, it actually flows over time. And you can do something with that as soon as it comes through. It's amazing, right? Because it enables us to process an insanely large amount of information with constant memory. We don't have to load that big file. We can process it chunk by chunk. It's fantastic. It's super cool, right? This is a question for you, though. How many of you understand node streams? Somebody, okay. Okay, so this is going to be a little bit of quiz time. So, quiz time for everybody. I don't know, because we need to do a bit entertaining after dinner, maybe a beer or two, I don't know, or three if you are brave. So, you know, you probably have heard about this on data. And you probably heard about the Writable event. We're going to talk a lot about those two. Now, who can tell me the difference between close and finish? You're not involved, Dave. I'm sorry. So, it is a nice thing. That is the. So let's start talk about end. End is emitted when you have a readable stream, something that you read from, and when we have finished reading from the stream. Finish is emitted when we have a writable stream, when it's finished writing, right? Obviously. And then there is close. Now, close was not there for a long time. It was there in some streams that were emitting that, some other streams were not. So we actually have standardized it in one of the later versions of Node. And it ended up, it represents where the underlying resource has been emitted, has been closed. And why is this important? Because neither end or finish are emitted in case there is an error. So if you just need to dispose your resource or do some activity when that resource is disposed, you need to listen also for error and do something with it and blah, blah, blah. While with close, you can actually say that this goes there. You know, there is also some mess with destroy. Also, destroy was not there. So if you want to destroy a stream, some method had a destroy. Some streams had the destroy method, some other didn't. Was not standardized, and I implemented it in Node 8. I botched it completely, so Node 8's destroy method is broken. Sorry, my fault. And in Node 10 was fixed, so use Node 10. You should do that anyway, because Node 8 is going out of maintenance at the end of the year, so upgrade to Node 10. By the way, I am involved, I maintain the thing, okay? I maintain Node streams. That's part of my job, okay? So, anyway, it's a mess, and we're going through this mess for some more time. So, okay, let's talk a little bit of data. Okay, so this thing was called like streams 1. So essentially, we are creating a read stream, and we are spitting out, emitting data event as soon as something is available. As soon as data is available. Well, there is a problem. This is push-based, okay? So essentially, we are reading from the thing and just say, take data, take data, take data. And if you want to give it stop back, you need to call the stream, says, stream pause. Hey, I'm receiving too much data, stop. Not really convenient, okay? And then the stream finishes when end is emitted. Yes, you did. I copied that code from you. High five. Because of this, handling back pressure is hard. Okay, so that was stream 1. They were probably at the point of node 0.8. Kind of not a great idea. So, then, thinking of making something easier to use and more, easier for people, we invented the Readable event. And the Readable event, as you can see, it's easier. No, it's not. Completely useless. But the nice thing here is pool-based. So essentially now, we are emitting Readable event when there is data to read from the stream. So we are not spitting out data. We're just informing the consumer there is data for you. Take the data, okay? And then you need to, read from the stream to get the data and do something with it. And this model is more performant. And because, there's not this kind of stop. You're only reading the amount of data that you need. And this way is less problematic. Not really usable, though. And yeah, as I said, it's more performant than the other one, but harder to use. So, and then we enter the bad part. Error handling is complex. If not saying something worse, but I wouldn't put it on a slide or saying it during when a talk is recorded. So, this has been on the example for Node.js for a long time. How many of you have written this type of code? None? I don't know. It's like this code. You did right. So this is the problem with this code, is that it is going to leak memory. In case there is an error reading the stream, or an error sending it out, especially if there is an error on the response. Let's say these are an HTTP server. So, that connection can be truncated at any time. Now, if that connection is truncated, nobody is closing this stream, and this stream stays alive forever, or for a long time, because there is a file descriptor underneath. And that file descriptor is never going to be closed and cleaned up. So essentially, you are creating a memory leak. So the right way is to use this nice pipeline function that we provide from Stream that you can use to write to automatically close the stream if there is an error. So hey, this is better. Or you can just use a framework and forget about the problem. Probably better way. There is a problem in maintaining all of this. It's that all the features, the best features of Node.js are based on streams. So if you're reading files, you're using streams. If you're serving stuff for the web, you're using streams. So if I try to change them and fix those odd cases, I'm going to break everybody. So it's a little bit of a conundrum here. I want to fix the bugs, but I can't fix the bugs. Or better, we are slowly fixing the bugs. Slowly. So there's a little breakage at every version of Node on some edge cases of streams. I'm cutting some pieces every time to minimize the breakage, but reduce the pain. And then async await happened. Do you like async await? I know Benedict loves async await. Thank you, Benedict, for making that fast, by the way. That was nice. my feeling of streams and async await is that if you mix the two, you make a lot of popcorn. Okay, the two do not play well together in any point of view, from any point of view. Okay, it's just a total mess. So you can't really use them together. So there is that, yeah. Again, I cannot make them promise aware without breaking anybody. I cannot make them a nice promise interface on top of them because I can't change the behavior. Okay, so there is that. So we have a question now, and it's how to improve the usability of Node.js streams. Dave, our media team wants you to take pictures, just so that you. Thank you. Anyway, so how can we improve the usability of Node? Fantastic. Okay, we are making a little bit of a show. So how can you improve the usability of Node streams without breaking anybody? So my answer to this is JavaScript. And just use JavaScript. How can we make them just play well with native JavaScript syntax? And my answer is async iterators. Async iterators are amazing. One of the most underused features recently that's been introduced by TC39. So this is how async iterator works and how async generator works. And you know, you define an async generator with this nice syntax, and you can use this yield operator. And you can use await in it and yield. And that's super easy, right? And then if you want to iterate on this, you can just use this syntax for await, let chunk of iterator, and then concatenate things, and you're just iterated over something that is completely asynchronous and promise-based. So it's a really nice syntax, right? It's really nice to read, and you don't have to use like, you know, this own data, blah, 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 and use all. You can just use JavaScript. So as part of my work in the Node Core team, we collaborated with TC39 and validated that the async iterator proposal could actually be implemented. We could actually implement, make the streams, the readable side of the streams, async iterable. So, you know, we did a proof of concept based on Babel, blah, 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 a long time ago. And we verified that we could actually implement them in a way that makes sense. And we had all the pieces, all the APIs to actually make that happen. So what you can do right now in Node 10 and Node 12 is you can just iterate over a stream, just use pure JavaScript. You don't have to do anything at all. You don't need to know any Node API. We just do the thing for you. More importantly, one of the nice things here is that in case of an error, we automatically destroy the thing from you. So if you throw inside your for loop, if you throw here for some reason, we automatically close the stream and dispose the underlying resources. So there is nothing really that you need to do, and it just works. So there's no memory leaks, okay? No problems. We also added, in Node 12, we have added a nice little thing to create a readable stream from async generator, which is also pretty cool because then we can integrate it with all the stream modules at all the streams API. So you don't have to know, oh, now I need to call write here, but what about back pressure? And what about all those crazy things that I might not know about? So I don't have to worry about any of that, and I can just use this nice API, and I'll just get, and I can just use pipeline to connect the two together. And it's way better because again, I don't have, if I have some API that's producing some data, I don't have to create a new create a new stream adapter that 9 people out of 10 are going to do wrong on the first go. It may become easier from Node 8 to Node 10. We fixed some internals, so some bad internals, but it's better. But it's still very easy to get wrong, and you can just use plain JavaScript. You can use a generator. This is a generator, but you can also use an async generator for that. So you can use. The nice part about using a generator is that this is just an iterable. This returns an iterable. So this means that everything that is an iterable you can pass. You can pass in an array. You can pass in a buffer. You can pass it whatever you want. I'm going to see this in a moment because it's demo time. And of course, it supports also async generators. So it's demo time. So demo gods, maybe with me. So okay, so I have a bunch of files that I'm going to go through. So this is a very simple demo. And this is how you would create, you create an array with a lot of elements, not really fancy. And we can create a readable stream. And we are just pushing data on the stream to get those out. Now, this code, it's easy to get wrong. And it behaves differently between Node 8 and Node 10. But let's not enter in this way. I think in Node 10 it's OK. OK, don't use this in Node 8. In Node 8, this creates a memory leak. So odd stuff. So what you can do is you can do Node 1, and it spits out all the values. OK. So what we can do with readable from is we can just pass in that array in, and it will just work. And note that we are still using our old school on data. So we are just doing node 2, and VM use 12, because if I use node 10, that's not there. Yeah, still working, OK? So it's actually nice, because it's a nice syntax, right? We can also create a generator. And this is slightly better because, we can avoid allocating that big array, and we just allocate things in our buffer. Still works the same, right? And we can move to 4, and we can actually consume that just using an async iterator. And that's, we're not using anything anymore from streams. We are just using pure JavaScript. So let's just run that. And again, it still works exactly the same. Note that async, this way of consuming string using async iterators, is actually as fast as readable, because we use readable inside. And thanks to the fantastic work that Benedict has done, this syntax costs nothing, almost. So, comes for free. And again, we can also use promises. So we can also use an async iterator here. So you can actually do await something. So you could potentially do sleep 100 milliseconds, and we need sleep. So require util. By the way, never wrap anything manually because you're going to make a mistake. So use util.promisify all the single times, please. I've corrected so many of those bugs in my life, so don't. I don't want to fix them anymore. And now you can see that's actually they're actually coming out at 100 milliseconds each. So we are consuming the data as soon as it's produced, and we are not allocating any more memory than what we need. So this is not needed. So yay, 6. Note that if we read a file, we can consume a file. Note that we need to do this rest set encoding UTF-8, because otherwise those will be buffers. So let's try this, and this spits out the file. But what we could do is we could do 2 uppercase on our chunk to get it uppercase. And now it's all uppercase. It's nice JavaScript uppercase. I don't know if this makes sense. And note that if we remove this, that's a big buffer. OK? So, hey. Now, this is a bigger example. I'm not using useStrict, by the way, but I should, as Benedict said. So, we are creating a server here, which receive a request calls this print function that is async, and I'm also adding a catch handler. Now, if you're doing anything on the web and you're using an async function, you have to have somebody that puts a catch handler for you, otherwise you will create a memory leak again. So put that. I'm sorry. Working on that. So what does this print function does? Well, this print function takes the stream coming in and just count the number of characters that are passing through. And it's return and say it's received the total number of characters. Then on the server, we are creating a duplex, and then we are piping getting a stream, piping it to our duplex, which is just our request. What is the request? Oh, it's just an HTTP request. Yes, piping that there, and then piping that there. It's not a duplex really. It's just a request object. And then when we get a response, we are piping it to standard out. So we are running 7, and then let's see, and then it counts the number of characters, and it's actually nice. I made it 124 characters on purpose. Sorry, I am whatever. A little bit of OCD. So note that I'm using this finished module because it's actually needed for making sure that this is actually finished, so we can actually spit out the correct numbers. Anyway, this is this is how the thing works. It seems very simple. Was not simple, super simple to implement. And now we're going to unveil in a little bit further on what is missing and how it's done. So what is missing on this API? I focused the first chunk of my talk talking about Writable. So what about transfer streams? Okay, because you want to read some data from a stream, and then you want to transform it, and then you want to pipe it back somewhere else, right? That's what we have done so far in all examples. This thing could be this is not a thing at the moment, okay? This API does not exist. This is speculative APIs. I hope somebody is working on it. Maybe somebody is working on it. Is playing on the phone. Thank you. It would be very nice to provide this type of syntax where if we can just write a transform by writing a function that use for await. Yeah, I know. And that just yields something. And then we can write it to the destination. And we can just combine things easily in this way. However, this is has still some problems. Because if you know how streams work, you have the readable stream here. It has a buffer, right, for back pressure. Now, this is both a writable and a readable. And a writable has a buffer, and because it's a readable, it also has a buffer. So this thing has 2 buffers. And then there is another buffer here. There is a lot of buffering in a pipeline. All of this is needed to make things work. However, it might not be needed for just if we are just processing things with functions. Okay, we are doing this to make it compliant with all the interfaces, but we could avoid it. And in fact, I would even like to have this API, which actually is even better for me, so that I can just pass a functions to pipeline, so that I don't have to, even create that transform stream. So I can just have a buffer here, and this is pool-based, because it's based on readable. So this is pool-based, and then this goes into the write stream in the end, which is cool. So we are avoiding a lot of buffering, and it's going to solve a lot of performance problems with streams, with stream processing. Because for await is extremely fast, so we can concatenate a lot of those if pipeline had this logic. At this point in time, it doesn't. This is a speculative API. Okay, this is streaming to the future, right? So this is the future, and it's just JavaScript, right? So I can, doing some certain things here. And then there is another point. What about Writable? I talk about Readable. I know more or less what to do, what we need to do for transfer. What about Writable? Well, I don't know. I wrote this, but I don't like it. So if somebody has better ideas, I would love to hear from you, because there is no equivalent of an async iterator
for a writable side of things, okay? So we cannot really implement them for that. So that is the problem. And so I wrote this code. So there is this nice build write function that I'm going to show in a moment that basically returns a write function, okay, that is just promise-based. So I can actually, you know, await, because streams do not play well with promises, right? Told you. That was the beginning of the talk. And then remember that we need to await finished, so that we know that the stream is finished, right? Again, this code is not nice. I don't know what to do, and if you have ideas, let's talk. This is how it's implemented. Can you understand what this does? Essentially, this thing is doing some very bad stuff. So there is a major difference between streams. One of the reasons why streams and promises do not play well together and play very badly together is because a streams emits an error whenever the error happens. So if the socket gets truncated, we emit the error immediately. However, a promise, it's just a Schrodinger cat box. Up until you look into the promise, you don't know. So if you want the streams to behave in a promise-based world, you need to do this very horrible thing, which is basically, if there is an error, put it in a variable and wait for that to happen. And then you're going to, you know, if that error happens when I'm writing again, I'm rejecting. However, this type of code can have a lot of bugs. So it has a lot of bugs already after I wrote it some months ago. So I'm not liking it. So if we have any nice ideas or not nice ideas or about this type of APIs and how to implement them, please let's talk, because it's actually very, very, it's very important. So we need to get better at this stuff. So now we're going a little bit one level deeper and show you how all of these work and how we have implemented, what we have implemented so far. So it's all JavaScript, okay? That's it. Well, a little bit more. So there is a protocol. There is an Async Iterator protocol. So an Async Iterator is just an object which has a certain, it's an interface. It needs to implement a certain type of method that has certain signatures, and that's it. So we can add, we can make any object async iterable if we want to. So it doesn't need to be an async generator. Okay, you can use any possible object that you have and make it async iterable. It's pretty cool. So what you do, and what this is come from straight from Node Core, you just, you know, you attach to the prototype of your object a symbol.async iterator property that returns your async iterator. Okay? Note that we do this type of horrible trick here. We do a require inside this thing, so we have a lower startup time. So if you're using serverless, you are happy. If you're not using this feature, we are not loading this feature. Anyway, how is this implemented? Well, a couple of things. In order to conform to this protocol, you need to have an async iterator needs to have this type of origin prototype, which is the prototype of an async generator function, whatever. I don't know. Somebody from TC39 did this for me. I have no clue why, and I'll probably never know. Dan probably knows. It's probably in the spec. Yeah, anyway, there was a lot of discussion about this. I just said, whatever, I don't understand it. The key part here are these a bunch of methods. It's these two methods, this next and this return. So next is called to get a promise that will be resolved when there is a new value available. And return is called every time you exit from that for loop. So if you break, your stream is going to be terminated, okay? So when you start a for await, you are supposed to consume all the streams, or it will be terminated. It will be destroyed automatically for you. So you don't leak memory, okay? If you want to do something, some more fancy stuff, just do partial consumption and those type of things, use the old API. You know what you're doing, okay? Internally, we've wrapped the readable event. Because we've wrapped the readable event, it means that everything is pool-based. So whenever your for loop wants a new value, we are actually going to the stream and say, hey, give me the next value, okay? So it means that we allocate the lowest amount of memory, the lowest possible amount of memory, and the buffering is done in the best place, which is probably C++, and the buffer in the operating system. So we don't have to do all this buffering in JavaScript, which is pretty cool. This is where it's implemented, and I recommend everybody to go and look things up in Core if you don't know and if you want to learn more about how things work. And I just want to show that things are complex and provide a hint on how complex things are. Not that we are doing this crazy error trick that I showed before, so that if an error happens, it will reject in the next time it looks for a value. And this is, again, to make things work in a promise world. There is a bunch of things about destroyed, and with a nice long comment, because I tend to forget about these things, so I wrote a long comment explaining it. I don't remember why, but I will need to read the comment. We are doing a lot of things here, and wrapping and creating promises and so on. We also work. This code also allocate the lowest number amount of promises, which is a little bit insane to some extent. So, and also the lowest number amount of closures. So whatever. And then we create a bunch more stuff and so on. Note that we use finish to know when a stream is done. Okay, and it's actually cool. So anyway, I just want to show the code, to tell you where it is, and so that you can look it up and read it. And please find bugs, because I would like to promote the usage of this thing. So if you can find bugs, I'm so happy, so we can fix them. Please report them if you find them. Okay. So a nice bad part, and talking about the future of streams, I hope I still have some time, is about what working group streams. How many of you know what working group streams are? Somebody is, okay. How many of you know what fetch is? Okay, you're using WHATWG streams on the web. Hey, okay. If you try to use the streams APIs for fetch, not .json like everybody's using, but if you're trying to use the more advanced stuff and consume things in a streaming way, you are using WHATWG streams. However, those things are completely incompatible with Node streams. There's a lot of bad blood being spilled there. I'm not going to open that bad blood. Well, that's the situation. I was not there yet, so not my fault. Not my fault. This is the thing, okay? So this is how you deal with the stuff. So you have this pipe2 method and you pipe them a readable to a writable, and then this returns a promise so that you can actually deal with things. This is an example from MDN. So I'm just reporting the example from MDN. You do a fetch of a turquoise image, and you await the body, then you get a reader, and then you need to read from the reader, and it's a lot of code, okay? And it's a lot of code, and you have this thing called the controller to do things with it. I don't know. It's and then more stuff to display the image. They are complex as the other guys, okay? Both things are really hard to use, okay? That's the net result. Streaming is really hard, okay? Writing, at this point in time, we don't know how to write a stream API. That's my current point of view, okay? That's a net line. So why we want them in Node.js Core, why we would like to have them in Core, it's to be compatible with the web platform, which is a cool thing to have, right? So you could write the same code and be truly isomorphic and blah, blah, blah. If you're using Node fetch is not fetch. So it does not implement this. It's using the Node Core streams instead of the WHATWG streams. So there are differences there. So people are complaining, of course, and for good reason as well. But then if you change it, it's become less useful because it's not compatible with the rest of the ecosystem. And And if you want to have fetch in core, probably we would like to have fetch in core. We will need to solve this conundrum a little bit. And there is a lot of other work being done on WHATWG streams. So the web worker probably going to use some web streams. There is stuff in code that's running in Cloudflare workers that's using WHATWG streams. And you might want to use the same code maybe on Node.js, and now you can't because of this, so it's a problem. So there is a lot of discussion about having this type of APIs in Node Core. So this is why. Now, if you want to add them to Node Core, it's a big problem, because if you want, then the whole ecosystem of Node is based on Node streams, and now you're adding this thing that's not talking with the others. So you have an HTTP endpoint, and that's returning a Node stream, not a WHATWG stream, and what are you using now? And if you want to replace them, it's going to be really hard. Are going to be really hard. So, and it's a lot of work, really, really a lot of work. Like write an HTTP implementation. I'm maintaining that as well, whatever. But yeah, they're kicking me out. Okay, yeah, I'm almost done. I'll say a bit more fun and more jokes about you. I don't know. One nice thing about async iterables, WHATWG streams is they are going to be async iterables as well. Hey, fun magic moment. So, in fact, I would like to reach a point where you can get a WHATWG readable, and pipe it to some function, use pipeline and pipe it to some function, and pipe it to our node Writable, and it all magically works because of async iterables. So that's the vision. That's my vision, at least, to fix our problems, okay? Because just use JavaScript, right? That's the thing, just use JavaScript. Don't invent any more crazy APIs for stuff. So if you want to get involved, we are Node.js, we are looking for new collaborators. So that's good. And again, NearForm, we are hiring. So talk to us. And if you need some help with your Node.js, please, and more. And thank you.